Imagine a world tens of thousands of years ago. Humans huddle around flickering fires in caves, their shadows dancing on stone walls. These first sparks of controlled fire marked the beginning of humanity's journey, our first mastery over the natural world. From here, we learn to craft tools, build shelters, and eventually harness the wind, the sun, and the rivers. Every leap from the plow to the steam engine, from electricity to computers, is a step toward a future that stretches far beyond our planet. Mikio Kaku, in his vision of the future, builds upon the Kardashev Scale, a method of measuring a civilization by the energy it can control. Today, we are roughly at type 0.7, a civilization still limited by the energy of our planet. Yet, through ingenuity and ambition, we have the potential to rise to type 1, mastering our planet, to type 2, harnessing the power of our star, and even to type 3, controlling the energy of our entire galaxy. This journey is not just about technology, it is about imagination, cooperation, and the human desire to explore the unknown. Could humanity, from humble beginnings in a cave, one day become a galactic civilization? A Type 1 civilization, often called a planetary civilization, is one that can use and store all the energy available on its home planet. This includes solar, wind, hydro, geothermal, and even tidal energies. Humanity currently sits around 0.7 on this scale, meaning we can harness only a fraction of Earth's total energy potential. Imagine a planet where every structure from skyscrapers to rural homes is powered sustainably. Deserts are covered with vast solar farms. Coastlines harness the constant pull of tides. Wind turbines spin on every ridge. Geothermal plants extract heat from beneath the Earth. Energy scarcity, war over resources, and power outages are relics of the past. Becoming Type 1 isn't merely about technology. It requires global coordination, cooperation, and foresight. Countries would need to work together, sharing energy resources and information. International politics, economic inequality, and climate change are the major hurdles. Solving these could mean mitigating natural disasters, controlling weather patterns, and even beginning planetary engineering projects like redirecting rivers or stabilizing tectonic activity. In a Type 1 civilization, AI and supercomputers manage energy grids, predict weather, and optimize agriculture, making the planet far more efficient and livable. Humanity could even begin to terraform nearby planets or moons, experimenting with life-supporting environments as a first step toward Type 2 expansion. If fully realized, a Type 1 civilization could achieve near-total planetary sustainability. Cities floating on water, energy beams transmitted wirelessly across continents, and transportation systems powered entirely by clean energy. Everyday life could resemble a seamless blend of natural ecosystems and high technology, where human ambition and planetary health are aligned. A Type 2 civilization, also known as a stellar civilization, goes beyond mastering its planet. It has the capability to harness the entire energy output of its star. The sun releases roughly 384.6 yottawatts of energy every second, more than 1 billion times humanity's current annual energy consumption. The most famous theoretical construct for a Type 2 civilization is the Dyson sphere. It could take the form of a vast swarm of satellites orbiting the star, capturing its energy. These collectors would absorb sunlight and convert it into usable power, transmitted to habitats, planetary colonies, or interstellar ships. To become Type 2, humanity would need technological mastery far beyond our current capabilities. This includes asteroid and planetary mining to obtain trillions of tons of raw material, self-replicating machines and robotics to build megastructures over centuries, and advanced AI and quantum computing to coordinate construction and energy distribution. Life in a Type 2 civilization would be spread across multiple planets and space habitats. Humans, or their descendants, potentially enhanced biologically or cybernetically, might live in massive space stations orbiting their star. Artificial ecosystems could simulate Earth-like environments, complete with oceans, forests, and weather systems. Cities could glow under artificial skies, and transportation might include magnetic rails spanning orbital habitats or warp-enabled starships powered by stellar energy. The implications of harnessing a star are staggering. With that energy, a civilization could move planets to prevent catastrophic collisions, shield inhabited worlds from solar flares or cosmic radiation, and ignite new stars or manipulate existing ones to power far-off colonies. Type 2 civilizations might manipulate black holes as energy sources, drawing rotational energy from them or even creating artificial singularities for propulsion. With such control over stellar power, energy scarcity would vanish entirely. Even minor errors in construction or coordination could have catastrophic consequences, given the scale and energy involved. A Dyson swarm would require precision on a scale of millions of kilometers, and any collision could disrupt entire orbital systems. Maintaining social cohesion and governance across vast distances would require advanced communication systems, possibly through quantum entanglement or exotic physics yet to be discovered. A Type 2 civilization represents humanity's potential to step fully into the cosmos. It is a species that no longer fears the limits of its planet, but instead uses the energy of stars to power life, exploration, and intelligence across entire solar systems. It is a civilization on the verge of transforming from planetary inhabitants into galactic architects. A Type 3 civilization is the pinnacle of what Kardashev imagined, a civilization that can harness the energy output of an entire galaxy. The Milky Way contains 100 to 400 billion stars, each radiating unimaginable amounts of energy. Controlling even a fraction of this would dwarf anything humanity currently understands as possible. A Type 3 civilization would be able to manipulate stars, black holes, and entire star systems. Its inhabitants or their descendants would have the technological and cognitive ability to design and operate projects on galactic scales. Imagine moving stars to optimize energy collection, constructing artificial habitats around multiple solar systems, or using black holes as energy generators or propulsion devices. The organization of such a civilization would likely rely on advanced artificial intelligence and autonomous systems capable of managing energy, resources, and communication across tens of thousands of light years. Biological life as we know it might exist only in select habitats, with much of the civilization operating through machine intelligences. Humans might merge with machines, becoming post-biological entities capable of surviving cosmic timescales and the harsh conditions of interstellar space. To reach this level, a civilization would need to solve challenges far beyond Type 2. Energy distribution would require either unknown physics or extremely efficient storage and conversion. Communication across light years would necessitate autonomous decision-making or quantum-entangled networks. Resources, stars, planets, asteroids would all be mined, moved, or repurposed for energy and habitat construction. Inhabitants of a Type 3 civilization might experience life on multiple levels: biological or cybernetic individuals on orbital habitats, integrated intelligences operating as part of a galactic network, and entities capable of perceiving and influencing events on a galactic scale, potentially even controlling gravitational dynamics or the life cycles of stars. Type 3 civilizations are likely post-scarcity. Energy, material needs, and most resource limitations would no longer constrain its inhabitants. Conflict over resources would vanish, replaced by collaboration across vast distances. Projects could span millennia, like constructing artificial stars, redirecting galaxies, or stabilizing black holes for energy production. Managing a civilization that spans thousands of light years requires not just advanced technology, but new forms of governance, ethics, and intelligence. Humans might need to evolve biologically or digitally to comprehend galactic events or communicate effectively across such distances. A Type 3 civilization turns the galaxy itself into a living, dynamic system under intelligent control. Where Type 1 masters its planet and Type 2 its star, Type 3 transforms the galaxy into a network of energy, habitats, and intelligence. Speculations about Type 4 and 5 civilizations extend even further. Type 4 civilizations could harness the energy of an entire universe, controlling not just galaxies, but all galaxies within the cosmos. Type 5 civilizations might access multiple universes in a multiverse scenario, manipulating the fundamental constants of physics, creating universes, or traveling between them. Achieving these levels likely requires post-biological intelligence. Biological humans might be unable to survive the timescales and harsh conditions involved. Advanced AI, consciousness uploaded into digital substrates, or hybrid human-machine forms could be necessary to comprehend and manipulate the cosmos at such scales. Even if such civilizations exist, their presence might be undetectable to us. Their activities could appear as subtle cosmic anomalies, unexpected energy distributions, strange gravitational patterns, or engineered structures that only reveal themselves across millennia. The journey from fire-lit caves to galactic engineering may only be the beginning of what intelligence can achieve. Currently, humanity remains Type 0.7, still dependent on fossil fuels, limited renewable energy, and uneven technological access worldwide. Yet, seeds of Type 1 civilization already exist: massive solar farms, wind turbines, advanced AI managing energy grids, and international scientific collaborations. The road to Type 1 involves more than energy collection. It requires global cooperation, education, and sustainability. Climate change, political conflicts, and economic inequality are the hurdles that must be overcome. Achieving planetary mastery could take centuries, but humanity has already demonstrated the ability to rise to global challenges. The eradication of diseases, the spread of digital communication, and the exploration of space. From Type 1, humanity could transition to Type 2 by extending our reach into space. This includes building orbital habitats powered by the sun, mining asteroids for raw materials, and developing self-replicating robotic systems to construct megastructures like Dyson swarms. These steps would allow humanity to tap the full energy of our star, enabling interstellar travel and settlement across multiple planets. Even modest steps toward Type 2, like space-based solar power or asteroid mining, would fundamentally change society. Energy scarcity would vanish and civilization could focus on knowledge, exploration, and creativity rather than survival. Reaching higher levels of civilization requires solving profound technological, social, and ethical challenges. Energy management is complex. Ethics involve manipulating planets, stars, or black holes. Governance must coordinate resources and AI systems across planetary or interstellar distances. Cosmic events like supernova or gamma-ray bursts could threaten entire civilizations. Opportunities are equally vast. Fusion energy could provide the leap to Type 1. Space colonization could jumpstart Type 2 development. Advanced AI and robotics allow for galactic scale construction and management. Scientific understanding accelerates, mastering physics, biology, and material science to make the impossible possible. Our imagination and ambition are the most critical resources. Every technological advance, computers, electricity, satellites, fusion experiments, brings humanity one step closer to planetary and stellar mastery. A Type 2 civilization could manipulate star systems like Lego blocks, moving planets to create optimal habitats or energy networks. A Type 3 civilization could do the same on a galactic scale. Humanity's potential is bounded only by the laws of physics, and by our creativity and cooperation. From the first sparks of fire to dreams of galactic empires, humanity's journey is a story of ingenuity, curiosity, and ambition. Michio Kaku's vision reminds us that the future is not predetermined. It is shaped by our choices, our science, and our willingness to explore. The question is not whether we could become Type 1, 2, or 3, but whether we choose to rise to that challenge. Every solar panel, every rocket launch, every scientific discovery is a step toward the stars. And perhaps, one day, the tiny spark our ancestors discovered in a cave will illuminate not just Earth, but the entire cosmos.